Okay, this is the semester 2 test review. Seniors, you're taking your test Wednesday and Thursday, the 25th and 26th of May. And then underclassmen, you're testing on the 1st, the 2nd, and the 3rd. The 1st is 6th and 8th period. 2nd is all the odds. 3rd be 2nd period and 4th period. Seniors will be in Mr. Little's room. Okay, so number 1's asking to describe the transformations of the parent function f of x equals the square root of x to the function g of x is the square root of x minus 4 plus 5. So it's minus on the inside. Let's go into the right, 4. It's plus 5 on the outside. It's going up 5. We had that acronym IHOD over. I stands for inside. O is outside. H is horizontal. V is vertical. O is opposite. E is exact. D is domain. R is range. So IHOD is the x, over is the y. So number 2 is asking for us to write the equation in the domain of the function f of x equals the square root of x plus 6. So I can either switch x and y and solve for y. I get y is equal to x minus 6 squared. Or I could go through and look at y and then look at y inverse. So I'm looking at my original function. The first thing I did to x was take the square root. Then I added 6. So for the inverse, I'm going to look at that last step on y and do the opposite. So I'm going to subtract 6 and square. So that still looks like y equals x minus 6 squared. The domain, f of x and f inverse have a special relationship. The domain and range of f are related to the domain and range of f inverse. If I switch x and y, x is domain, so that becomes the range of f inverse, and the range of f is the domain of f inverse. So if I can find the domain of f of x, the range of f of x, I can find the domain of f inverse. So if I graphed it, it's a square root, and it's shifted up 6. So it should start at 0, but it's shifted up 6. So the range of this is 6 to infinity. So our domain here is 6 to infinity. So number 3 is asking to find the x value in the equation. I have my radical isolated, so I'm just going to square both sides. I get x plus 2 is equal to 5 squared is 25. Then I need to get x. I'm going to subtract 2. I get x is 23. For this one, you can put in the calculator. I'm going to make a table. Looking at x and square root of x, then x minus 2 and the square root of x minus 2 minus 6. So I'm going to start with my y values. My y values are the integers 0, 1, 2, 3, 4, 5. The x values are going to be these values squared. So 0, 1, 4, 9, 16, 25. 16, 25 are obviously off our grid, but I'm shifting it to the right, so they're really not off our grid. They're really off our grid. So x minus 2, I need to look for a value that's going to make x minus 2 equal to 0. It's going to be positive 2. So I'm pretty much adding 2 to all of these. So then for this, square root of x minus 2, I'm looking at these y values because I shifted it, but my y values didn't change from this column. Then I'm subtracting 6. So instead of 0, I have negative 6, and then negative 5, negative 4, negative 3, negative 2, negative 1. So 2, negative 6. 3, negative 5. And 6, negative 4. Then 11's off, but I can kind of pinpoint where it's going to be. Kind of draw my curve. Trace over it in red so it's more visible. Write a function with a domain x is greater than or equal to negative 2. The parent function f of x equals square root of x. There's an infinitely set of equations that has these two things. So pretty much any function you write that has a positive coefficient like 2, x plus 2, and then you can shift it up and down however you like, 'cause that's not going to affect the domain, it's going to affect the range. You can say plus 5, or you could just go with the more simpler y equals the square root of x plus 2. You can go with any kind of variation as long as that number out front of the square root, the coefficient is positive. You can go with 1,000 minus 6,000, whatever. As long as you have that x plus 2 and that the number out front is positive. Number 6 is asking us to solve the rational equation, that's unit 8. I think most everyone had a harder time with that unit. But I'm looking to find the least common divisor. The LCD. I have 3, 6, and 2. So 6 is the least common divisor. 2 only has 1 and 2 as a multiple. So I'm kind of just looking at these numbers and I'm trying to find what number will go into each of those. So I can look at my common factors of 2. all my multiples rather, 2, 4, 6, 8, 10, 12, whatever. 3, 3, 6, 9, 12, 15, and then 6, 6, 12, 18, 24. 12 is common throughout all of these, but so is 6. So 6 would be my least common divisor. So I'm going to multiply each fraction by 6. So 6 is on top, 3 is on bottom, so those can simplify. 6 divided by 3 is 2. Here I have 6 on top and bottom, so those simplify to 1. 6 and 2 simplify to 3. So I'm left with 2 times x minus 3 is equal to x minus 5 plus 3. So I can distribute that 2. Then I have more x's on the left. So I'll subtract that x over here. Add 6. So I get x is equal to 4. Or you could put in the calculator. y1 is x minus 3 divided by 3. Then y2 is the rest of it, x minus 5 divided by 6 plus 1/2. And then you go in the table and you find the common y value. And then that x value that corresponds is the answer. So I'll show you what that looks like. So put in fraction x minus 3 divided by 3. X minus 5 divided by 6 plus 1/2. And go to my table. So 1/3, and that's 1/3. I made that into a fraction. Yeah, so now it's more obvious. It's 1 and 1/3. Or 1/3 and 1/3. So my x value is 4, so my answer is 4. So number 7, I need to write an equation and graph the following transformations from the parent function. I should say f of x is equal to square root of x. So they're reflected across the x-axis, so it's negative square root. Shifted left 4, so it's x plus 4, and then it's shifted down 2. So I have minus 2 on the outside, and that's equal to f of x. Well, I'll say g of x, because f of x is the square root of x. So I want left 4, down 2. So it starts there, and then it's going to kind of bow down away from the x-axis. That's reflected. It would come up and bow away from the x-axis on the positive side, but it's reflected. So I can make a table. Kind of didn't leave myself room, but... So I'm going to go with the usuals. So negative, so it's going to be, well, negative 0 is 0. Negative 1, negative 4, negative 2, negative 3, negative 4. And then I need to find what x value is going to shift those over. If I had negative 4, that would make this 0. Negative 4 plus 4 is 0. So basically I'm going to increase by 1. And then increase 3, then increase 5, then increase 7. Then I'm taking these y values and I'm subtracting 2. So I have -4, -2. I already plotted that point. -3, -3. And then 0, -4. Way over here at 5. And then 12 is kind of off here. Number 8 is asking me to solve the logarithmic equation. 2 times the log of x is equal to 8. So I'm going to divide by 2, and I get log x is equal to 4. So there's not a log, if there's not a base written here, it's base 10. So then I'm going to rewrite it. 10 to the 4th power is equal to x. Because the log gives me my exponents. My exponent's 4. So 10 to the 4th is x. So x is 10,000. Number 9 is a standard graph the parent function, y equals square root of x. So you can make a table and just put it in the calculator. So number 10 says find the value of x in the equation log base x of 25 is equal to 1/2. So there's nothing else I need to do except for rewriting it as a log, or as an exponential. So b to the x is equal to a log base b of a is x. So base here is x, so it's x to the 1/2. It's going to be 25. So square. So x is 25 squared. 25 is 5 squared. So 5 times 5 is 25, times 5 is 125, times 5 is 625. Or you could just put it in the calculator. Number 11 wants us to graph the parent function y equals 1 over x. 1 divided by 1 is 1. So 1 divided by -1 is -1. Then everything after that is going to be a fraction. So I'm going to say 2 is going to be 1/2. So 1 divided by 1/2 is 2. So it's just going to look like this. And the same over here. We see it kind of hugs the y and the x-axis. Those are our asymptotes. X equals 0 and y equals 0. So our horizontal. This is our vertical.